Let's learn how to illustrate the effect of temperature on the reaction rate using Maxwell-Boltzmann distribution curve. Before I show you the Maxwell distribution Boltzmann curve by overlapping lower temperature and higher temperature, I want to highlight that the area under the curve represents the total number of molecules. Areas under both curves given below 50 degrees Celsius and 100 degrees Celsius are the same. That means that the number of molecules is the same. Okay, for example, let's say I give 5 molecules. So under this area, 50 degrees Celsius, there are 5 molecules. Okay, but let us look at what does it mean. Okay, when temperature decreases, the number of molecules with kinetic energy larger than activation energy decreases. Okay, so for example, I have 1, 2, 3, 4, 5. Okay, let's say the number of molecules which possesses kinetic energy larger than activation energy only 1. Okay, if at higher temperature, 100 degrees Celsius, okay, maybe here I have 1, 2, 3. Okay, then the one that has larger than EA, I have 1, 2. Means if the temperature is higher, then the reaction will be, okay, the reaction rate will be higher because more molecules, when they possess kinetic energy more than activation energy, reaction will occur. Okay, now I want to highlight for Maxwell-Boltzmann distribution curve. What do you need to label? Okay, so number 1, axis first. Okay, so label energy and then fraction of molecules with energy E. Okay, then another one that you need to draw is the two curve. The one that with lower temperature and another one with the higher temperature. Okay, so you draw the curve first. Okay, so remember the lower temperature has higher curve. Okay, it has higher peak. Okay, and then the higher temperature will have lower peak. Okay, then there's another thing that you need to label, very important, that is the activation energy EA. Okay, then you need to remember to draw one line to show that this area are the area that the number of molecules which possess the energy, kinetic energy equals or greater than activation energy. Okay, another one, remember you must label T2 greater than T1. Okay, so this one is the lower temperature, T1. This one is T2. If question given 150, then you substitute on your own. Okay, another one is the shade. Okay, so you must know what shade that you want to use. Okay, here's written here, the shaded areas represent the number of molecules having kinetic energy equal or greater than EA. Okay, so you must write down this statement as well. Okay, so next one, let's look at this. High temperature must shade all of it. Okay, because we want to show that high temperature has more molecules. Okay, maybe here 1 only. So if let's say here I have 4, you can see that the higher temperature I have 4 molecules, but for the lower temperature, the blue one only has 1 molecule. Okay, now for the shading part, okay, I want to emphasize again, usually students having problem to draw that. Okay, so what I would like to recommend for the shaded area, okay, let's say I draw again a smaller version. Okay, another one higher. Okay, let's say this is the EA. Okay, you must show, okay, if you don't want to use shade like blue color, I will actually use dot for higher temperature. Okay, higher temperature, I use dot. Okay. Then for the lower temperature, I will use line. 1, 2, 3, 4, 5. Okay, so in this way, you can see that the lower temperature is with the line. Then the higher temperature includes all over the area. That is the dotted one. Okay, so it is easier to see. Okay, so these are the parts that I want to emphasize for Maxwell Boltzmann distribution curve. Okay, for the explanation part, please refer back to your notes. That's all.